Let's explore how we use free fall ideas. In this situation, we have a student who throws a ball upwards under our motion detector, and there's three events. So the ball moves upwards during interval 1 to 2 while it's in contact with the student's hand. At event 2, it leaves contact with the hand at a velocity of 3.3 meters per second upwards. And then at event 3, it will reach its highest point. So let's draw a sketch showing what's happening here. Here's the ball in the student's hand at event 1. The goal of this problem is to help us understand when free fall begins and ends. We often overlook intervals of time when other objects like the hand are in contact with the ball, which will be free falling later on. Labeling the givens is really helpful for building our understanding of this situation. At event 1, the ball begins moving upwards, and so that means its velocity at this moment in time is equal to 0. We're told that when the ball leaves contact with the hand, it has a velocity of 3.3 meters per second upwards. That'll be v2. When the ball reaches its highest point, it's been slowing down during this interval from 2 to 3, so that at event 3, its velocity is now equal to 0. We can identify the interval of free fall because that's the interval during which the only important interaction is the gravitational interaction with Earth. And so that'll be between events 2 and 3. So during this interval here, we'll show this by writing the acceleration during this interval, a23. This is going to be our free fall acceleration. Now, we've called upwards the positive y direction, so the acceleration is going to be downwards, negative 9.8 meters per second squared. So this is the given information that we have for this situation. Now, the interaction diagrams in the first diagrams are going to help confirm our understanding. For interval 1 to 2, the ball is in contact with the hand. So, the system object, the ball. It's interacting with the hand and Earth. With the hand, we'll call this an applied interaction. With the Earth, we'll call this gravitational. So we can see there's more interactions than just the gravitational one. So this interval is not free fall. Let's draw the first diagram. The ball is a point particle. There's going to be two vertical forces. And now let's pause for a moment to think about its motion. From event 1 to 2, its velocity starts at 0 and it is speeding up. If that's the case, the acceleration has to be in the upwards direction. So that means the upwards force must be larger in size than the downwards force of gravity. So during our first interval, this is not free fall. There's this additional interaction, and the ball is moving upwards, speeding up, and it's going to leave contact with our hand at event 2. Now in interval 2 to 3, the ball is still our system. The only thing that's interacting with the ball during this interval of time is the Earth. The hand is no longer in contact, so this interaction disappears. We're just left with the gravitational interaction with the Earth. So this picture here is what shows us that this is now an interval of free fall. And one of the strange things is that the direction in which the ball is moving is not important. Here it happens to be moving upwards during this free fall interval. We normally associate the word fall with things moving downwards. But it just depends on what interval of time we're focusing on. We're not interested in the ball's trip back down. The only thing that's important here is that the gravitational interaction is the only interaction that's present. That's what makes this a free fall interval. When we draw the force diagram, we have one interaction, So we have one force. Because we're going to do this really carefully, we want the force of gravity vector that we draw over here to match the one that we've drawn before. This shows our understanding that the force of gravity is not changing in size. The mass of the object is not changing. And so in this situation, that force must point down. It must be accelerating downwards. And that makes sense with our understanding over here. At event 2, it's moving fast. Event 3, its velocity is 0. And so it has to be slowing down during this interval. And that also agrees with our picture here. The acceleration is downwards. Acceleration downwards. So we've now done all the important free fall thinking. Everything else now is just using our force and motion skills in order to analyze these force diagrams and answer the questions. So the careful work is thinking about the interactions during the two intervals and reminding ourselves that at its highest point, the velocity of the ball is going to be equal to 0. So that's how we use our free fall understanding in order to set up a problem.